All right, so to begin with, I just wanted to go a little bit through this code and see if I can refactor it a little bit, make it a little bit easier to work with, take out those global references and stuff like that. So that's kind of the first thing that I wanted to do, just to simplify some things here, to take out all of these references to variables that we have here, and just kind of put them into a class. So what I wanted to do was just make a class here. Just call it simple game. That's my class, and then more or less we can just change the names of these things in order to fit it into the class. Say, okay, instead of calling init game specifically, I'm gonna just make an init function here on the class. I basically want to take all of these here and say, all right, inside init, since I'm initializing this class, so these are just part of the class at this point. That means we can more or less go into all of our functions and take out these references, but that'll still leave us with, so I'm going to take the global references out wherever they are. So there were some questions from students about how to go about kind of losing these global references. So now I'm going to pretty much take all of my functions and just say they're part of this kind of main class here, this encapsulating class that I'm going to call simple game. But that also means that each of the functions will then need to be class functions, and that also means that I'm just taking each function and adding self to that. That also means that each of our references to the variables will now, instead of being global variables, have to have self in front of them.
Is this the preferred way of when we do this assignment? Do you want it?
In the end, rather than having the global references all the time, yes, I would say this is better.
Okay.
But you can, especially in these first two assignments, you can more or less choose how exactly you do it. I'm not requiring you to set up classes or classes for objects, things like that, but as soon as your program grows, it'll be so much simpler to keep kind of classes for objects separate, even in separate files, and structuring your code in that way. But it's not too big an assignment to just do all in one file. After that, however, I strongly recommend starting to structure things like that, having classes for objects, and each object knows how to draw itself and how to update itself, and so on and so forth. So you have these specific kind of object-specific functions on the class, update function for each class, display function for each class, that are global update functions and display function calls. So let's just start with this. So I'm hoping if we save that I'll get errors on the variables, at least if I try to run it. All right, I'm gonna have to run it here. See if we get specific errors. All right, now at least I've got markings here where there are references to these variables. So in that case, I'm just going to have to manually edit this. It doesn't necessarily have to be inside this class. Instead, we could have a separate class that kind of holds all of these global variables, and then we'd reference that class from outside. But it's simpler to have it like this, either self or the name of some particular class that holds the variables that we're using, so we're not kind of mixing up these global variables with local variables and getting weird errors based on that. So this is just a local variable here. So if you feel you've gotten this, just continue on your assignments, or if you're watching this on a video, just jump over this part. But I think in general, all right, so I think in general it's nice to just have all of these steps in the video rather than skip them, which is why I generally kind of program these things from scratch and then continue on from what we already had. So instead of init game, we're now going to do something like game equals simple game. Sorry? So the question is, would we have this while true loop inside the init function? I don't think I'd have it in the init function, but I'd definitely have it in one of the functions in the class. So I would do something like add a function here inside the class and say define, let's just call it start game, self, and inside that I'd have the game loop. So while true, self dot game loop, and here we'd say game equals simple game, and then game dot start game. For whatever reason, my computer is super slow here and showing kind of the code completion and things like that. Then we'll probably just have some errors on variables that I haven't changed to class variables yet, and we can just kind of just eat those up little by little. Tries to run. If, and then again self dot there's a motion, self dot shooting, angle, so I'll just run this a few times until it stops getting errors and see. This is actually ridiculously slow, even for this computer. Okay. Just gonna have a bunch of these. Angle. And we just have this OpenGL code, which mainly, okay, we need to projectile position. Let's see now. So in the end, I just want this to work exactly as it worked before. The next thing I'm going to do after I kind of finish getting this finished is I want to take things like the projectile and move that to a separate class. So then I can make several of those and they know how to update themselves and know how to. Okay, started running, but as soon as I hit forward, it went into this if loop and here self.angle. Try to use variables that weren't defined. So now I'm hoping that I can at least move the spaceship. The question is what happens when I try to fire. Alright, already fixed that. Okay, so now we have this super simple game here with one ship, and whenever I shoot the projectile, it's just the same projectile jumping in, which is a problem that all of you have already kind of overcome in the first assignment. The idea of making several instances of the same thing and drawing them every single display function. So if we want to do that in this game, that can be kind of our first mission here. To say I want these projectiles to add up. I want new projectiles and some way of making them disappear and such. The first thing I'd like to do is to say, all right, I'd like to set up a new file here. In this case, I'm just making a separate file for this class. You can also combine this and have an objects file that has all the objects in it, or OpenGL functionality class that just has your drawing functionality and things like that, easily accessible with function calls. So if we start with this and just say we're going to have a class projectile. This can be any class at all, class moving box, something like that. And all I want to do here is I want to say, well, the first kind of problem is what information does a projectile need? And what changes do we need to do to our code to access those things? Like, if I just want to draw this projectile somewhere and move it someplace, what's the first things I need?
Position.
A position, all right. And what type would I have that position here in my code? I already made these classes here point and vector. So it might be nice to go ahead and say, all right, I'm going to make another new file here. And what will we call this? Basic functionality, or any ideas where I put my point and vector and stuff? Vector math.py.
Oh.
Something better than that.
Object.
Objects.
Don't like most objects have position and possibly a velocity.
Yeah. Let's just say base objects. So I'll just call the class that, or the file here, .py, and I'll go into my simple program here, and I'll take my class's point and vector, and I'll put them into base objects. And now the first thing I'd like to do, I'm going to take projectile here and just do pass and hope that this won't pose a problem. I want to see that my original program runs if instead of doing that, I go ahead and do from base objects, import everything. So let's see if this simply so there is another faster way to run your program. The only reason I'm doing this is because, all right, so it's running. I'm using my positions and vectors. So now I've refactored simply by moving this to base objects here. my point and my vector, and in simple GL program where I use those, I just import it instead. So now I can go ahead and projectile here as well and do from base objects, import everything, and then I should be able to say, okay, I need position the question is, I'd probably just want this to be part of the constructor for this class. So let's say position and speed. So self position equals position, self speed. Okay, so I'm not even referencing the class directly here. Okay, what's the complaint here? All right. So what can my projectile do? What do I need to put into this class in order to be able to call some functionality on the class projectile and make it do things? Like for any object that I want to have in a computer game like this, if we just look at our main program here, we have simple game. It has a function called update, and inside update it's doing a lot of stuff with these projectiles. It's building them. It's also here projectile position. Okay, we want to do this, except we want to do this for every single projectile. Now there's only one. We want to be able to do this for all of them. So this is something that we imagine our projectile should be able to do itself, right? We don't want to have this code all over the place. We want to have something simple. Like what would we want to have instead of this code here? Self dot projectile dot what? How much do I want my projectile to be able to do? How little do I want to tell it? Do I want to tell it update your speed or do specific things, or do I just want to say update yourself? Just you update. You as a projectile should know how to update yourself. You know your speed, you know your position. Does that sound like a reasonable thing to ask my projectile? So what I want to do here is simply say, yes, I would like to send it the delta time. Ooh, whoops. I seem to have jumped to a completely different location in the file. And then just going to do undo. My sausage fingers went ahead and did something weird. So yes, I want to send delta time in here. So this is what I want to do, but I don't have this operation, and I don't even have a separate class or an instance of the class for projectile. But this is what I want projectile to be able to do itself. So define update. That should be a class function, and take some variable delta time. So my update function on projectile should just take the time that has passed. So that's the only thing I need to send to it. Tell projectile, you know how to update yourself. The only thing I need to tell you is how much time has passed since you updated yourself last, so you know how much you should change. So the projectile itself should be able to say self position plus equals self speed, or we can actually, since I've used motion here, kind of as this way to say kind of a vector speed rather than just a single numeric speed. So is this the only thing that projectile needs to be able to do in its update function?
You have some standing.
Oh, cool. Spemotioned. I like that variable name. I did that on purpose. All right. So, is this everything I need for this update function, do you feel? You can answer quickly, then this video will be shorter. like this is a simple thing. Yes, let's just say that this is all it needs. Later we can add something like if it hits something, blah, blah, blah. But then we have to decide, does the projectile itself know how to do those comparisons, or is there some other class that knows how to take a projectile and do those comparisons? Doesn't matter just now. What else does the projectile need to be able to do? I'd say we've taken kind of, or we're about to take what it does in the update function, and we've taken that and kind of made it separate. We'd like to take whatever we do for the projectile here, this stuff, and we'd like to put that into a separate display function as well, and just be able to say projectile.display. Let's take this, go into projectile, and say you need a display function. In that case, I'd like to take at least these things and just import them in base objects, so that anyone who's importing that is importing this as well, hopefully. So can we say that this is a normal display function for an object? So it translates, it goes to a position. We'll look at that in more detail later, kind of playing a little bit around with transformations. It translates to where it's at, and then it just draws a point. So this is a super simple display function. Now, what a display function for an object in general might do is translate to where it is, rotate so that it's correctly oriented, maybe scale so that we draw it in the correct size, and then it draws itself. So these are kind of the things that a single object would do. Do I need GL push matrix and GL pop matrix here at the beginning and end of the display function for this object? Or the obvious answer is no, you don't need it. It depends on what I want to do. But what GL push matrix and pop matrix does is it kind of saves the current matrix in push matrix. Then I do some changes like this GL translate. It changes my current transformation matrix that decides where things are. What happens when I do pop matrix is it takes the matrix that I put on the stack up here and it puts that into the main transformation again. Meaning that everything I did in here is kind of reset by doing push matrix and pop matrix in the end. So I can do all the transformations in the world here. If I do push matrix at the beginning, pop matrix at the end, that means I will leave the current transformation in OpenGL the same as when it came to it. And that would be something that's nice for a function that calls these to trust, right? Does that make sense? That if I'm a main function and I tell projectile to draw itself, and when it finishes drawing itself, it leaves me with a different transformation in OpenGL. It leaves me with a different kind of local coordinate frame for my world than I started with before I called it. There's no way for me to kind of get back to where I was. I could have GL push matrix and GL pop matrix before and after every call to display functions of objects. Yes?
No, just wondering, when you push the matrix to current,
Yeah?
you want to do like some translation on the matrix? Or you have to use some matrix to do the translation? Or
So GL translate. Okay, so if we go into, the idea is what matrix am I using here? So we're using this old style static pipeline OpenGL right now. We're going to go into shaders and stuff where we have to define our own matrices and send them through the pipeline and all kinds of stuff. But for now, what we're doing here, if I go into display, is by setting GL matrix mode here for GL model view, I'm saying the model view matrix, or what we're really interested in is just the model matrix, is the current matrix that I'm using. So if this is the last way I call GL matrix mode with GL model view, That means that is the matrix that I'm affecting through all transformations. And again, if we go into projectile here and look at this GL translate, that will affect the model view matrix. So this is kind of just hiding the matrix manipulation from us. It's taking, but that's simply what's happening. It makes a simple translation matrix, the one that we looked at where we have an identity matrix except for the fourth column. Then we have these numbers, basically this for x, this for y, this for z. And then it takes that and it multiplies it to the right side of the current model view matrix. So we may have transformed all over the place. Our world may have first kind of transformed to its own inner world where this projectile lives, and then the projectile transforms to where it's at, so on and so forth. The idea is, though, that you don't need to know anything kind of outside your own transformations. The projectile just imagines that it can project, or it can translate to its position, and it doesn't need to know in what kind of world that position lives, because it's whatever is outside and whatever called it that knows what previous transformations have been done. This doesn't matter. The idea is, I, by calling GL translate, am affecting the main model matrix in OpenGL. And the model matrix is basically the local coordinate frame that we're drawing into. And every time I call GL translate, I'm not changing the translation to something different. I'm adding a translation on top. And then I call GL translate again, and I add a translation on top of that. I call GL rotate, and I rotate the entire coordinate frame. And then I call GL translate again, and I'm translating within that new rotated transformation matrix. So these transformations just add and add and add and add to my current coordinate frame, which OpenGL keeps track of. So GL push matrix and pop matrix give us a way to kind of keep track on at least taking away changes that I've made if no one else is interested in them. And projectile can think, all right, I'm going to save whatever matrix was at the beginning when I started. When I was called, I don't know what the matrix is, but I know that I'm going to store that because I'm going to make some changes. And I know that this change is not something anyone else is interested in getting as well. I'll have your question in a moment. And then after this is done, after I've made my changes, which may be several transformations, I draw myself, and then I call GL pop matrix to say, I want to go back to when I pushed this matrix. I want the current transformation of OpenGL to be back to what it was before I made my changes. Your question?
Assumption is that GL push matrix leaves an identity matrix behind. Right? It takes the
No.
one I have, stores it, and leaves
Okay.
identity behind.
It takes the one I have and copies it and puts it onto a stack, but leaves the original behind.
Okay.
Okay, so that's a good question. So GL push matrix, we have a current matrix. It leaves that unchanged. It just takes a copy of it. Then when I call GL translate, I'm just continuing to affect the same matrix as I had before. So GL push matrix and GL pop matrix give me a way to continue transforming on top of previous transformations without me necessarily knowing what they were. So instead of having to know them in order to copy them back, I just trust that GL push matrix and GL pop matrix can get me back to where I was. So yes, after I call GL push matrix, the current transformation on OpenGL hasn't changed at all. I'm still working in the same one. If I wanted to end up with an identity matrix, I'd have to call GL load identity specifically myself. If I do that, then I'd end up with an identity matrix. But in this case, I'm not interested in that because the projectile lives within some world, and that world is defined in some outer class. And projectiles shouldn't be able to affect that, which is why I don't want to do load identity and then translate. I want to do push matrix and then pop matrix in the end. I could also do push matrix and pop matrix before and after I call display functions on objects, but that would just make the other code look more cluttered. So I like, personally me, this is just the way I like to do it. I like to do this at the beginning and the end of the inner display functions, just to keep the main code less cluttered. All right, enough on this. We'll we'll look at this better soon enough. Anyway, so projectile now knows how to display itself. And the only thing left now, so like I said earlier, if I want this, if this is happening really, really slow when I do Control F5 in order to kind of debug this, I can just do Python, yeah, it was super slow as well, Python simple GL program, and that'll run it. But what I don't get then is as many helpful error messages and stuff. So it's quicker for me to use this just to see that things are working. I haven't made the changes yet though. So just to see that it's working now, I now want to go in and take all the projectile specific code, and I want to use the projectile class instead. So alright, instead of me having self projectile position like this, I'm going to do something like self.projectile equals, then I probably have to import from projectile, import everything. Alright, just a new instance of this class. Point 100, 100, just, and vector, let's just make it 0, 0, just to make sure that it's still drawing itself when we at least start. So then this is going to be out, projectile position and projectile motion. But I am going to keep projectile speed in here, because that's going to affect kind of the projectile when I build it. Alright, in update, so this is making a new projectile. So instead of this, we have to take the same thing as here. So now I'm making a new projectile. In this case, I want to say this is going to be the position that I make it at, like so. And the vector that I send in is going to be whatever I had originally here. I'm hoping I can do something like this, just in order to make it a little bit cleaner. Like so. Alright, so now I'm sending those, and the self-shooting thing is part of my spaceship, so I'm leaving that out here. What do I do instead of this? Instead of self-projectile position plus equals all of that, I just want to call update on it and send it my delta time. Okay, so what I changed is when I make a new one, I just say self-projectile is a new projectile. In the end, we want to add new projectiles to a list, but let's wait a minute for that. Then we want to go into display here. We want to say, instead of all of this code, we want to say self.projectile.display. Sorry. Yes, J is missing, projectile. Let's see if it just works without changes. Nope. I still get my... Yeah, true. Obviously this is just position because it's inside the projectile class. Let's Let's see again if we can run this. Alright, at least I'm moving and the projectile is drawing itself, and it's updating in the same way as before. So again, I have the exact same functionality I had before. The only thing that is nicer is my code is a little bit nicer to read. So now what? What's the next thing I'd like to do to make this? We can maybe add a little bit to the functionality now rather than. Do you feel like this is something that's helping you get into where you want to be in your assignment, or do you feel like you've already gone past this and I'm just reiterating stuff that you already thought about and solved?
Helpful.
Helpful? Okay, then I'll continue.
One question.
Yes, please.
If you can fit it in, if not, it's okay.
Yeah.
You were talking about the vertex arrays or something in your assignment.
Ah, yes.
No idea what.
Okay. I was talking about vertex arrays. Ignore that. I'm sorry, that's a copy-paste error from. So vertex arrays we will use in later assignments. Yeah. Because I took the decision now to start with this OpenGL 1.x type of programming, which means we can do it much simpler. We can use this GL vertex and GL begin and GL end. The vertex arrays are something that we don't need to worry about just yet. So yeah, I'm sorry, I left that in the assignment description, but you can ignore the idea of vertex arrays. We're just using, vertexes directly, like here, we're just calling GL vertex. So yeah, ignore the whole thing about vertex arrays, and if you can send me an email or something and remind me of sending out a memo on that, that's okay. Vertex arrays we'll use in the next assignment, because then we'll start using shaders, we'll start using OpenGL 3.0 or 3.x style code, and we'll be using our own shaders, and we have to set up vertex arrays, and we have to set up our own matrices, and all kinds of things get added to the complexity then. So where were we at? So do we feel like the next step should be to make more projectiles? Would that be something that's helpful? To see if we can take, now that we've made projectile into a class, we'd like to imagine that it'd be quick and easy to make it so that when I hit space, instead of my projectile disappearing where it is and kind of resetting itself in a different location, I instead would like for a new one to appear. So where would I start? Here maybe, instead of self projectile equals projectile, I'd like to do what? Self dot projectiles equals what? There's something in particular that I'd like to use there. Nice data structure. In Python, would this just work? Just say now I have an empty list. So we're going to throw this entirely out and just say now I have an empty list of projectiles. That means, how do I change this then? Instead of saying self projectile equals this, I would say self projectiles are there a lot of people who haven't used Python, so maybe the syntax of Python isn't the quickest thing. All right, so what I'd do is I'd say self projectiles is now a list. So I don't need to new it. Python just, this syntax simply tells me it's a list. Self.projectiles, I would just say something like append. It's a nice function. So now I'm adding a new projectile here with all the same stuff that I had before. So I'm adding it to the very end of the list. I'm appending one. Now how would I change this code here? I need this from you. I just need some feedback here. Do a loop. So a for loop for projectile. Yeah. Well, no, for projectile in self dot projectiles, like so. So for every item in the list projectiles, I'm gonna give it the variable or set it to the variable projectile, and then I'm gonna say projectile, which is this local variable now, update. This should work, yes? And then I am going to go down to display. So more or less, in the end, once we have kind of our base code set up, if we add objects like this, say I'm going to add a new type of spaceship, we should be able to simply build everything that matters inside the spaceship class, the new spaceship class. Then all we should need to do is go into display and add a loop to go through all of those spaceships, or if there's just one, just call display on that, and go into update and call update on that. Also, if we have some kind of general object class that all the other ones inherit from, it might be even simpler, because then we just have one loop that calls update on all our objects, one loop that calls display on all of them. Then all of our different objects simply inherit from that. So then we can say, if I need to make a new object, I simply make it inherit my base object. I do all the code, the display and update things. Maybe some of it is inherited, so I only need to do the specific code here. Then all I need to do is in the kind of initialization functions of my code, I just add one new object and it's of the new type. And then voila, it has become part of my game. So here, instead of projectile display, I now do same loop basically as before for projectile in projectiles. I call display for it. So now we can see what happens. Maybe everything crashes, maybe I'm trying to do something with the original projectile here. Invalid syntax. Yes, I did that. Let's see if I can do. This again to make it a little bit quicker. Okay, so now there's no original projectile. And now I shoot again, and shoot again. And this is basically what I wanted, right? So you can decide what you feel that I demonstrated here. In my mind, it's mainly that once we put the work into taking something and put it in a separate class that just updates and displays, adding more of that becomes so much simpler. Whereas if I were instead to say, okay, I need more projectiles, I would have taken projectile motion and projectile position and made each of them into a list, or whatever, or added more variables. Just making something into a class. And in these types of programs, generally what each object needs to be able to do is update itself, given the time, and display itself. And if they have that, then our update and display functions can pretty much remain the same as they are now, even simpler as we take more things out, except we just add a new loop for every new type of object that updates and displays it. We can go in here and add more things. GL color. Do I have random here? Yes. Let's import that as well. Do I have to self.rand equals and I think this works. Am I doing this right? To make an instance of random. Dot. It's really difficult when the code completion isn't. Rand int, that's the function I'm looking for. No, isn't there a rand? Random returns, yes, something from 0 to 1, perfect. So we can just make our new random color for each projectile. Will this do that? What will it do instead?
Change color every frame.
Change colors every frame. Okay. So if we want a new color for each projectile, we'd like to do this in the initialization and basically give each projectile a new random color and then store that color. So then we'd need an actual color variable or 3 integer variables that we store that in, and then we use that here. Not going to go through that because this is not important enough for that, but we're going to see, whatever we put into the display function here will then be part of the drawing of each projectile. Oh, I was trying to run projectile. Python. Okay, so we have these little blinking projectiles instead now. Actually, it looks a little bit cool. And you can see that my speed is added to them as well. So if I'm accelerating, and each of them goes a little bit faster, I've just lost myself. Fair enough. All right, other interesting things that we can do here, other things that we can refactor out. What I'd like to look at here is maybe, we should really go more into the transformations themselves. I talked a little bit about them inside projectile here. But now I am again going to go into my, okay, this is my spaceship and everything. Okay, let's just go in here and add a little bit of code here. Well, one thing that we'd maybe like to do is we had somewhere, if I recall correctly, this is a sign. Did we not have a circle here somewhere? Oh, but let's take this code here anyway, and let's go ahead into just base objects and make a new class here and say we're going to make the class circle. We can say that circle has a radius. So self.radius. And it should know how to display itself. And actually, in some cases, we'd like this actually not to matter that it has any specific radius. We just want to always display the same circle. Then we can use transformation function to make it bigger and smaller. So I'm going to make this as simple as possible. Whoops, that was the wrong thing copied there. I'm going to take this here. I'm just going to throw this out. This doesn't matter. Okay, so in base objects, inside circle, display is going to do this. we are going to go. All right, we need math here. Let's just start with 0. Go up to 2 times pi. No, it was lowercase. So we're going to do line loop. Less than rather than less than or equal. Do line loop. Okay. These are pretty small steps though. 0, 5. Except we can't do this. We can do something like temporary angle equals 0. Say about this, we're going to make x equals the cosine of the temporary angle, and then we draw this vertex. Does this make sense to everyone, more or less here? We set some color. In this case it's line loop. Actually more interesting would be to do triangle fan. Okay. Alright, so now we have a display function for a circle. Let's see if we can use that here. I'm going to go in here and I'm just going to define one circle. Self.circle equals circle. And I want to go into here and say GL push matrix. Start with that and GL pop matrix. Just to be able to leave things as they were before we started. Alright, so I'm going to see what I can do here. I'm going to do 2 of the transformation functions. GL translate, and let's just start with a some position, say 200, 200, 0. GL scale 200, 201, and then let's do circle self circle dot display. Probably a bunch of things going to be wrong with this. We can fix them as they come up. Okay. Need to make the radius. I'll just make the radius 1 here. So I'm making a circle with a radius 1, and I'm just always going to draw that circle. The dot display takes 0 positional arguments, but 1 was given. Did I forget to have self in here? Always something. Okay. I know what's happening here. Can anyone tell me? Like, to begin with, what is this probably? Just in general programming terms. What's happening when my window is completely not responding? Eternal loop. Why is there an eternal loop? Like, where exactly in my code? Yeah, I'm never changing it. I'm saying while it's less than or equal to pi, but I'm never putting it closer to 2 pi. So temporary angle plus equals, let's say 0.1. 0.1. Let's see if that's it's enough of a circle. Ah, I hit the wrong buttons. Another nice thing about running it, not through this, but just by typing Python in there, is that it always runs the correct program. Now I'm trying to run base objects. What I want to do is run simple program pi, so I don't have to exit the base objects. Usually I have to go into the program I'm going to run that. Instead I can just remain inside the file that I'm editing. Okay. So now my spaceship is suddenly red as well because, you know. Alright, so I have this circle. It's obviously too big, but the only thing I have to do to amend that is just to make it a little bit smaller. Let's make it 2020 instead. Let's take this up to 400, 250. Alright, now let's start playing around with transformations a little bit. I did that again. Have to get it out of the fingers. Okay, so I have that circle there, but it's not really doing anything. But the thing is, the function that we're using to draw it is just drawing every time. Radius doesn't even matter, so we can just take radius out actually. And this is just circle, and it just draws a circle with radius 1 every time. We could put something in like in how many slices do we want to draw it, so a bigger one will have kind of more points or more lines, whereas a smaller one fewer lines. That might be kind of the only interesting thing to put in there. So let's try that. Slices. And do self.slices equals slices. How would I change this in order to do exactly this many points in my circle? So I'm basically changing the granularity of my circle. So instead of always growing temporary angle by 0.1, I want to grow it by what?
2 pi divided by slices.
Okay, 2 pi divided by slices, but I don't want to calculate that every single time. So I'll just calculate that in the beginning. Or I can actually go ahead and in here say, I don't need slices. What I need is self.angle change equals pi times 2. Well, I don't need those parentheses anyway, but divided by slices, right? So all I need to store here is the angle change. And then I can do temp angle plus equals angle change. That now means that wherever I made this circle, let's make it with 5 slices and see if it actually becomes a pentagon, which is what we expect from it. All right. Self.ang change. And now I'm going to remember to do Python simple program to get this up quicker. Oh, thank you. All right. So now our circle looks like a pentagon, which is fine. And I can go ahead in here and say, let's make it all just 20 slices, that's fine. But that means that bigger circles we could use, we could make a kind of granular circle class and a less granular circle class, or circle instance, and use them differing if we want to really optimize the time. So small circles don't really need all of those slices. All right, now we have kind of these base objects that we need to start playing around with this a little bit. So where was I going to draw this? Here, circle display. So now we're translating to here, then we're scaling it, and then we're displaying the circle. What if I want this circle to be some kind of center of a solar system, and then I want another circle that's orbiting it? How do I go ahead and do this? Now I have to start thinking about which of these transformations should affect both of them, which are part of the world that they're both drawn into, and which should only affect this circle. I'd say this scale is about this particular size of this circle. So I wouldn't like that to affect the moon that I'm going to draw after it, which means that I'm going to push matrix and I'm going to pop matrix here. I'm going to say this particular circle has its scale. After I draw it, I'm going to throw that scaling away. But I'm not going to throw the translation away. Why is that? Why don't I want to throw its position away? If my objective is to draw a moon that circles around this location, I'm not interested in losing this location. I want to have already gone there. So now that I'm there, I want to translate from there. So I'm going to go ahead and make another circle here. I want this circle to be smaller, but I want a new translation as well. I want to say before I scale it down, I want to translate to its place in the orbit, right? So let's just say I'm going to translate by x out to an orbit that's 100 pixels wide. Okay, so I have another one there, but it's not really orbiting. I need some motion. So how can I get that motion? I need some kind of orbit angle. Let's just add that here. No, we should be able to put this into some class that's a moon class and has its own orbit angle and so on and so forth. But again, saving time by just sticking it in here. Orbit angle equals 0. Okay, so what do I want to do with this orbit angle in my update function? Plus equals something per second. Let's say half a circle per second. Does that sound reasonable? Now we're working in OpenGL, and this is going to be a headache sometimes. When I call the math function like sine, we use radians, right? But when I'm calling the OpenGL translation functions or rotation function, we're using angles in degrees. So let's say 180 degrees times delta time. So this will be 180 degrees per second. So in every single orbit, my self dot orbit angle changes by that much. What do I do in display for my moon now? I have this translation, I need a rotation, right? Do I put my rotation before or after the translation? Okay. The answer was before. I'm going to try it after first. GL translate, no, sorry, GL rotate. And GL rotate takes in an angle, so I'm just going to say orbit angle. But then it takes in a vector, which I'm rotating around. And since we're in 2 dimensions, we're always really rotating around the vector 0, 0, 1. Right? Because that's the z-axis, which is not existing in our current program. So this orbit angle here, all right, self.orbit angle. Okay, can you see the rotation happening? Now I put it after. Let's go into our circle again, and again make the slices just 5. Okay, so now I can see the rotation happening. I know this is tiny. Okay, so the correct answer already came here, that we would like to, in our display function, do the rotation before. Well, let's just take that, put it here, and run this again. Okay, so now we've got an orbit happening, but it's also kind of rotating around itself at the same speed. All right, what if I want to put a moon around that one? Or to begin with, let's make this bigger. That was too tiny, so I want to see both of the planets larger. Where do I make that happen? Here. All right, let's make the center planet larger. Let's make this planet larger, or the moon. I want to make the orbit bigger as well. Where do I change that? In the translate, okay. Let's just double the orbit as well. Let's see what we've got now. Okay, an interesting thing about push and pop. If I go ahead here and skip this push matrix and this pop matrix, what do you imagine happens now? Or actually, no, we're pushing and popping here as well. So let's take this later one as well. What do you imagine happens to our program now? I think the solar system is going to be the same. But what's going to change is everything we draw after it. So we don't even see the spaceship that was there in the corner, because that's somewhere also rotating around this because we've scaled everything up. So it's scaled many times. Would have been cooler if it would have shown up every once in a while there. But if we add the push matrix and the pop matrix again, we're making sure that after we do these scales and these translations and all of that, we're going back to the coordinate frame that we were already working with. Which means that our spaceship will, again, oh, it's up there now. So there's obviously something. Let's see what the projectile does. Yeah, okay, this translation here was still outside. So we need to have that translation as well inside a push matrix and a pop matrix. And now we'll have all of this in its correct places. So you can see that all the transformations I do affect everything that's drawn after it. So the push matrix and pop matrix gives me a way to reset to where I was, but not quite to reset to an identity matrix. So what do I do if I want kind of a separate speed of the way the planet is orbiting around itself? We have a rotation here. So we rotate our current, one thing I'm going to do here, allow myself to draw this a little bit on the board here. This is a good pen. So we basically translate our coordinate frame that we have here, we translate it to some place, and then we scale it to a different size, and we draw our first planet. But before we scaled it, we called push matrix. So we stored this coordinate frame here. We stored it on a stack. So after we scaled, we popped it back off the stack and got back to here. So we scaled, we drew, we got the old one back from the stack. So we're back to here. But we're not quite back to here. At this point, we first rotate. And rotating means that we rotate our current coordinate frame here. Then we translate. And that translation happens within this rotated coordinate frame. So that's why we rotated first, then translated. When we translated first, we translated to here, and then rotated, and this was simply rotating around itself here. But by rotating first, then translating, in one frame we draw our moon here. Next frame, we rotate a little bit more, then translate, our moon gets here. Next frame, we rotate a little bit more, then translate, go to here. What if we want to add an orbit around itself? That is, it spins around itself. Then we also need to rotate after the translate. All right, so we can add that. What if we want to add another moon orbiting this moon? So we can start by adding this and say we need a rotation after this as well. And I can use the same orbit angle. I can just multiply it with something. It's always going to be an angle just changing constantly in a circle, so I can use the same angle and multiply it, or I can use a separate angle. So we can see what happens here. So now it's rotating at a different speed here. You can make it rotate the other direction, times minus 0.3. Let's say then minus 1.3. Did I forget to save? Yes, I did. It's already running here. Like so. All right, what if I want to add, let's first add another planet. So okay, now this is rotating a little bit backwards, fine. So we've got this planet, nice. I want to add another planet on a little bit of a bigger orbit. Is this whole thing just the way I want it? Do I need to stick something into here? Or do we just add kind of another set of this outside? If I want to add another planet, this one's not rotating around the moon, it's rotating around the original planet. So then I guess I have to pop matrix back out to just this translation, which is the translation to the center of the original planet. Then here we can rotate by orbit angle times minus 0.7. We can skip the rotating around itself for now. We need a bigger orbit for this. And let's make this planet a little bit smaller. So we just scale it differently. And then we draw the same circle again, except this circle is now drawn into a different coordinate frame. So that's the other one. It's rotating the other direction. Okay, so we went all the way back to the position of the original planet. Not all the way back to here, though, but back to after we translated to here, but before we did anything else, to add that second planet. What if we want to add a sub-moon around the first moon? So here we translate to the original planet. Then we push matrix in order to do that scale, display it, and then pop it again. We could do a little bit of a rotation here so that it just rotates a little bit around itself. 0.4, something like that. All right, then we go back to there, but we kind of make these orbits. Where would I have to stick it into this original planet or this original moon in order to make an orbit around that moon? Before, so this translation here is to the center of that moon, right? So I kind of want to revert to there. Does that make sense? What do I do in order, let's say I want to draw that moon here after this. What do I need to do to this to leave me at the correct position, being able to do whatever I want there? Okay, so I push before this, I pop after this. Fine. Actually, push here, we pop here. Yeah, we need that. Okay. What if I want this orbit not to be kind of added to the rotation that's already here? So I have this rotation. What can I do to lose that rotation? No, sorry, this rotation here. I want the translation, but the translation is affected by the rotation. So I can't really just push and pop now. What can I do instead? What can I do? So again, I'll explain this just a little bit on what I'm thinking about. Is this. Here I have a rotation happening of the orbit. And this is my moon. I want to do another moon around that moon. Except I don't want this moon, if I would simply have no orbit on it, it would still be orbiting always to the outside side of this. Does that make sense? I want, even when I'm here, I want my base angle to be here. And I want this rotation to be always kind of thought from this base angle. But instead, if I keep this angle in, the angle that this moon is rotating about, no, it will always affect it. But I want this rotation to happen. Then the translation, what do I want to happen to get back to here? Sorry? Yeah. I need to just rotate. I just need to just add that other rotation. So I need to take this rotation, which is like so. I want this translation to hold. All of this will basically go away. So then I can say I want to rotate by basically minus this. And let's try to draw another moon here. So I basically stuck it inside there. Before this then draws the other moon. So let's do its own translation. I'm going to skip the rotation now and just translate it to a little bit outside of that moon. So I'm negative rotating here. I'm translating, let's just say 65 out. Then I'd like to scale this particular moon. Let's just make it small, 10 by 10. And then I need to display the circle. So push, this translation, push and pop, this is out, push, push and pop, this stuff, then pop. So let's imagine this will work here and draw a small circle on the outside of that. Okay, so I'm not rotating it, but I've managed to stick it always to the right side, which means if I add a rotation now, that rotation should be, so if I now take a rotation, let's make it a slow rotation. So when do I want to add it? After I translate it, are you sure? Yeah, after I translate, I'll just be rotating it around itself, which is actually something we can do. We can kind of make a super fast rotation there and just see what it looks like. If my computer will ever. Okay, so now it's just fairly fast rotating around itself. But what we're interested in, copy, paste. Let's make a fairly slow. This is too small. Let's see. Slow rotation. Obviously, we could have kind of combined these in order to get that rotation, but you can see that it's very slowly rotating around itself, or rotating around kind of its moon, the submoon rotating around the other moon. So okay, the idea here is mainly that with these transformations, we add the transformations to one another. I add a rotation, then I add a transformation, say a translation, then I rotate, then I translate again in that rotated coordinate frame. I scale from there in order to draw things in the right size, then I pop that scaling away and then I continue. And push and pop just gives us ways to say, okay, I'm at a point here, I want to continue transforming from here, but later I want to get back to here in order to continue transforming from here again. And I don't want every single time to have to load an identity matrix and start from the beginning and add all of my transformations. And this is something that's integral in computer graphics. If we just look at things like just the idea of some kind of level that's a house in a computer game. And we have the house, and within this house we have locations for furniture. And so we have a bookshelf here, and we have another identical bookshelf here, and we have another bookshelf in this room. And we can kind of imagine that this house is positioned, kind of has its own local 0.0 here. So inside this house, this bookshelf has a certain position and orientation. So we can translate to here, we can scale it and rotate it so that the bookshelf is in the right place. But then we pop. So we push before we do that. We pop back to here, because then we push, translate to here, scale, and rotate so that this bookshelf is correct. We draw this bookshelf, then we pop back to here. We push, do all of those things, pop back to here, because now we're drawing this house, and it has a bunch of associated bookshelves that have these local positions. They don't have necessarily positions in the entire scene, because possibly this house isn't the center of our world. Instead, we have a road here, and we have other houses here, and another house somewhere else in the world. So after we draw this entire house, maybe we pushed at the beginning, went to here, pushed again, end up popping, and we go back to our main world, and then we push again, and we go and we draw the next house, and we translate to here, and then we have bookshelves, and we have bathtubs, and we have cookers and stuff, all of those with their kind of coordinates relative to the house that they're in, so on and so forth. So this is the idea of manipulating the transformation matrix little by little, adding these little base transformations, but being able to go back, not all the way, but just partially back, in order to draw other things within this same kind of local frame, and then going back to our global system, and then transforming back or translating back to other locations in our world, and then drawing things as relative to those local locations. Is this something? Yeah, question.
Yeah. Is it correct to think that, like, if you have circle shapes in your world, and the only difference between them are the size of them, you would become the model that are the same size, and draw them at the origin, and then scale them and manipulate them, using
That is the way these things are usually done, yes. So if you have these objects that are identical apart from their size and locations, you wouldn't really, you draw them into their own origin. So you, like models, like inside something like this, an artist would draw this particular model of a bookshelf as if it had its own 0.0 here. But whoever drew the house, they drew it as if it had its own 0.0 either here or in the corner or whatever. And whoever kind of draws this world, they imagine they have their own 0.0 in the center of the world. Then they just position a house like this, and the graphics program that they're doing this in needs to be able to say, okay, I just add this location to the house, so that every time I draw it, I transform to there, and then I draw this house. But the house, when it's drawn, is just sending in its coordinates, which are relative to its own center. Just like the circle that we did, it's just a circle that's a radius 1 circle. If we look at the code for that again, base objects here, we have our circle. This always draws the same circle. It is centered in 0, 0, because it goes with cosine sign around it, so it'll go basically always draw points that are 1 distance from the center all the way around, and that's all it ever does. And it's always a radius 1 circle, it's always just cosine sign. But when we're running our program, we're getting, well, these aren't proper circles, they're pentagons, but either way, we're drawing circles that have different sizes, different speeds, different locations, all over the place, using always the same function. And this holds true when we have more complex objects, like these houses or furniture, or kind of these base elements in computer games and in graphics programs. So yes, you're correct to assume that you have these circles or spheres, but you don't draw them at the origin and then transform them. It's more like you add the transformations to OpenGL's base matrix and say everything I draw from now on will be transformed by these transformations that I've added. So OpenGL is kind of like a state machine. And you can say that the state of the OpenGL state machine is changed from the outside when you call the transformation functions, when you call GL viewport, when you call GLU ortho2D to change the window. You change all of these things in order to change the state of the OpenGL state machine, and then you run it by sending vertices through. And every single vertex that is run through it will be affected by the same state of the state machine until you change the state again. So after you've called transformation operations, nothing that you will send through will be changed in any other way than from those. So you send vertices through. After you've sent them through, you change the state again by either reverting some of the transformations or adding new transformations or popping the matrix to go to a previous matrix and then adding transformations on top of that. Now you've changed the state of the state machine, then you draw things. But when you draw them, yes, you're kind of thinking they are drawn around their own origin points. They imagine their own origin being in the center of them, and they don't know any better, and they don't need to know anything that happens outside of them. The outside is manipulated by changing the state of the OpenGL state machine. Then objects are sent through that just believe they're being drawn at their own center, but in fact they're drawn all over the place because that's what the model transformation matrix does. Did that answer the question, or just allow me a little rant? Are there more questions on these things? Do you want to see anything in particular happen here?
Yeah, maybe like some collision. Is it complicated?
It's a little bit complicated here. Let's see what we can do about that. Some kind of collision. I don't know if we can use. Well, we can. We can calculate the actual positions of all these planets, but that's a little bit complicated. So if we go into base objects here, let's just make a box here. Go and say class No, wait. Let's go and make a class here for circle. That's called moving circle. And let's define init here for that, self, radius, position. Let's just make it simple for now. And this does, well, what does this circle need? Self position equals position, self, sorry, dot here, radius equals radius. Okay, what does a moving circle, all right, let's not even call it moving circle. Let's just call it, because I want it, the circle class is really just a base object that can draw a circle. Now we want a circle that's kind of there. It's an actual circle object. Let's just call it that, circle object.
You have self space radius.
Yeah, okay, there's an extra space there. Okay, so I'm not going to add motion to it. You can add motion to it as well as a vector and then update it just the same way as we updated the projectile. But for now, let's just say that it has a position and it knows how to display itself. Define display self. So what does this particular circle need to do in order to draw itself? If the only thing I need to know is the radius and the position, what code can I steal that we already did with the planets? Also, we're going to need kind of the graphical object here. So let's say self.circle equals circle with 20 slices. Let's make it a nice kind of good granularity circle. So what do we do in display? First, well, let's not steal code from the other side. Let's just write this up. OpenGL functions that I need to use. I'd like to push, yeah. I like to do that at the beginning, oops, push matrix. At the beginning and end of every one of these types of functions that I do. Okay. What do I also want to do? Now I have the circle, that's my graphical object. So I can draw that, right? Circle dot display. So that's simple enough. What do I need to do in order for this particular circle object to be where it's supposed to be? Translate to where? Self.position.x, self.position.y, 0. Okay, what else do I need here? Now I'm putting this circle where it's supposed to be. What else is specific about this instance of the circle? Need to be faster so I don't have to leave. Scale, GL scale, by self.radius, self.radius and 1. There's a comma there. Okay, so let's imagine that this display function here works nicely enough. Then let's make a circle object and just put it somewhere there. Let's go ahead here and say self.circle object equals circle object. Was it position first? Point 250, 250. Was it radius first? Okay, let's make the radius 50, like so. I change it to circle object because I'm not going to make it move now. Then you can expand circle object into moving circle that also moves around.
So it needs to be self.circle.
This would be self.circle.display. Okay, what I want to do now is I want to draw my circle object. So I'll just draw that somewhere here at the end. Here. Circle object dot display. Just to see if this works. It'll give me errors. Oh, I have one running here. Okay. Circle object is not defined because it's supposed to be self.circleObject. Okay, so there's my circle object. What I want to do now is I want to take every projectile that comes out of this spaceship and I want to check if it hits. So the main thing here, I'm not going to write complex collision code here for you because that's what you're going to do. But what I want to do is kind of just put these things in the correct places in our code to make sure that we're kind of thinking it correctly. So I want this from you. Where do I now want the operation that does this comparison? I'm going to allow myself, while you're thinking about that, I'm going to take all of this solar system code here and comment it out. Wait, this as well. Okay, so where do I want this function? There are a lot of answers to this. We could have one function that takes a projectile and a circle and compares them. Or we can maybe do this nicely here and say, let's have the circle object have a function that's called collide. And let's make it super simple. We're not going to actually have a collision response where things bounce off it. All I want to know is, does it happen? So collide self, and I want to collide it with a let's just say point. Fair enough. I'm just going to say I'm going to send a point in, and I'm just going to say, is this point contained within my circle? That's all I'm going to do now. I'm not even going to have it using delta time and everything to check when this happens and then it bounces off. I'm just going to check, is this point inside my circle? So how can I calculate this? I get a point, I have another point which is my self position, and I have a radius. How can I now check, in this particular case, whether this collision is happening?
Check if the point is in the distance of the center.
Okay, so I need to calculate the distance, right, between the points, between my position and the point. And what am I going to check about that distance?
Equal to or less than the radius.
Okay. Do I have to calculate the actual distance, or do I have a cheaper way? Did we have a dot product here? No. Oh well. Okay. So I'm going to say distance squared equals point.x minus position.x. So I have all math here, right? So was it pow? This would be this to the power of 2. No, wait. Python has a better one, right? Yeah. So this to the power of 2 plus the same thing except for the y, right? Okay, so this would give me the position squared, the distance squared. What am I going to compare the distance squared to? radius squared. So I'm going to say if my distance squared is less than or equal to is less than or equal to what?
Radius squared.
Yeah, okay, radius. I mean, self dot radius to the power of 2. So this is cheaper than taking the square root of the distance. Okay, so if this is true, I want to return true. Otherwise, I want to return false. So this is just a checking function. Now, where do I put this collide function in my main code? Like, what operation would be a reasonable place to put this? Update, because this is part of updating my model and making things disappear or making things bounce or whatever. So then I can go into my update function here. And so after we update these, we can either make a new for loop here for the collisions, or we can actually put the collision in there, in the other for loop. So if, what are we checking now? If projectile dot no, this was in base objects. No, this was, sorry, circle object. If circle object dot collide, if circle object and that will be self dot circle object dot collide with projectile dot projectile has a position here. Then we want to do what? Circle object dot change color, and let's make that function then. Okay, so in update I check my collision detection is calling the circle object collide with the position of the projectile. I'm going to make a function called change color on circle object, which is going to be my collision response. I'm going to go in here, I'm going to do change color, define change color, and I'm just going to take one self new color, and I'm just going to put that color on all of them. I'm going to go in here and say self dot color equals, just say 0.5. When I change color, I'm going to take a random again. We're always using random here in projectile. Like so, base objects. I remember there is a way to just use random directly rather than making a, but I don't remember it just now, so I'm just going to do it this way. Self.rand.random. Okay, so in change color, I'm going to say self.color equals this. And what do I need to do? Display here. I need to say GL color 3F self.color. So it'll be grayscale. self.circle object. This should be
When I get the vector in
here. Yes, okay. On a faster computer, usually it's quicker to just try to run and see what comes up, but this one it's nice to. Random is not defined. So I didn't import that in base objects here. Okay, let's see if we got something. All right, so the thing I want to see if I shoot a okay. So this tells me position. Yeah, self needs to be self.position. Point is correct. It needs to be self.position. This is the fun thing about scripted languages is these errors just pop up. Self radius, okay, the rest is correct. So at least what happened was that as soon as I shot the projectile, the comparison started happening. Okay, so this projectile goes past, this projectile hits. Well, something happened. It worked. Self dots. This says oh, okay. Change color. Didn't want a new color. Well, then it would have. Okay, you get the point. You can have the random outside it and send it in. You can have the random happening within. Just whatever fits your program. Wasn't using that variable. Didn't change the color though. I wonder if there was another.
It keeps different colors, so you don't see a difference.
So here's color, self.color. Well, I should see kind of a.
Is it on the circle object color definition, view color definition? You have like self.circle.display.
Self.circle object.change color. Then we have down here self.circle object display. Either way, let's not spend too much time on debugging this. You get the point. So the main idea here, so thank you for the question. I hope this answered some of it, but the main idea was more, like where do we put the particular code? Basically, where do we put the code that does these comparisons? In this case, I chose to take this one object, which was the big circle object, and then I have several projectiles, and I said I'm going to put this collision code on the big object. And then every single projectile, I take the position of that and send it to this object that knows its size, and it just checks this point against itself. It could also be a function that's outside both of them. Just a main function that says, does this circle collide with this box, or does this point collide with this circle? Either way, the collision function is just something that gives me returns true or returns false in this case. If, however, you would want something to bounce off of it, then you would have to say, okay, I have this object here, and it tells me that I hit something. What does the object need to return? In this case, you could design your system so that it actually returns the vector, which is the normal vector to the collision. To say, if I collided here, the normal vector to a collision is here, then that's the return value. If that's the return value, then the system that called this collide function, the update function, can continue and say, okay, I know what to do with this in my collision response function. So now I'm going to take another function, which is, if I take this direction and reflect it about this normal, what's my new direction? And then you put that direction to the projectile, and the projectile bounces off. So you have to think about, where do I put these functions? Where do I put the function that just tells me, did something hit something? Or the function that tells me, where did something hit something? Or simply, is something within the circle? And whatever it returns, can I use that information in order to get something like, how do I now change my main vector in order for it to be a new vector after it bounced off this? So on and so forth. So the questions regarding this. I think in most cases it's nice to just take kind of your main object and say they know how to collide with simple objects. An object knows how to collide with a circle, or it knows how to collide with a point. In this case we had this big circle, and it knows how to collide with a point. And then you use those functions to call from the update. And you need one collision detection, which is the true-false function that I made there. Number two, collision response, which was simply calling change color in my case, but you need a more interesting collision response. And if that collision response needs to bounce, then the collision detection needs to tell you what was the normal that you need to reflect about at this particular point. Or if you're just checking sides that are always kind of horizontal or vertical, then it's simple enough. If you're checking against the horizontal side, you know the normal. You know you just bounce like this. If you're checking against something that's always, well, horizontal was the first one, vertical, then you know it bounces like this. But if it's a more complex object, it needs to